Hi, welcome to my video on inverse trig functions, arc cosecant, which is the reciprocal of sine. And again, we start off with the unit circle, who is the radius of 1, and this point, 0, we have a 1, 0. This is a 90, we have a x is 0, y is 1. This is 180, x is negative 1, y is 0. This is 270. And x is 0, y is negative 1. 360 is 1, 0. And the cos is the x-coordinate of these points, and the sine is the y-coordinate of these points. So let's look at the graph of y equals cosecant theta, which is 1 over sine theta. So cosecant theta is undefined if the sine theta is equal to 0. So sine is the y, so the y is 0 at 0 degrees, 180, etc. So 0, this is a 90, this is 180, 270, etc., 360. So the sine is 0 at 0, vertical asymptote, at 180, vertical asymptote, at 360, vertical asymptote, and that's a negative 90. This is a negative 180. This is the vertical asymptote at negative 180, negative 270, negative 360, vertical asymptotes. And this is cosecant is the reciprocal of sine, so the sine graph starts at 0, goes to 1, 0, negative 1 on the 270, 0. So the sine graph is doing this, and we continue down to negative 1, up to 1, and then we go like this. So there's the sine graph and the dot, but notice it's undefined at where these are vertical asymptotes, and notice that the sine graph is positive here, so cosecant is the reciprocal, so start at 1 and we go upward like this, and this is a negative down here, so the reciprocal of negative 1 is negative 1, and then it goes down like this. So this continues, so right here this is negative, so it goes down, starting at negative 1. And this is positive from here to here, so its reciprocal is going up. So that's the cosecant graph. But I want to look at the inverse of the cosecant graph. And notice that when you draw a horizontal line, it passes through many points. Down here passes through many points. So we have to restrict the domain, and the restricted domain, well, the sine is the reciprocal of cosecant, or cosecant reciprocal of sine. So sine is from negative 90 to a 90, so is cosecant. So cosecant goes from, and I'll draw that down here, that right here, so it's this restriction here, and it's vertical asymptote at 0, and it's restricted here, so we'll start at this part here, and so that's the restrictions, so that its inverse will be a function. So this point here is we have that's theta, so that's a 90, giving us a 1, and right here this is negative 90, and it's negative 1. So notice that the domain goes from negative 90 less than or equal to theta less than or equal to 90. So we go from negative 90 to a 90 for the domain, and theta cannot be 0, not equal to 0, because again, it's the vertical asymptote at 0. Sine is 0 at 0. Right here, sine is the y is 0, so cosecant is undefined. Now, when we do its inverse, we reverse, so we go from 90, which is here, to negative 90, and we go from negative 1 to a 1. So your domain, which is theta, becomes your range, and your range, which is your y, from 1 to negative 1, is on your domain. So we have a vertical asymptote here, horizontal asymptote here. So this is at the theta is at 90 is the vertical asymptote. So, and we go, now the graph goes from 90, comma 1 to 1, comma 90. So 190 is here. So the graph goes towards the asymptote from that point. And the other point is, let's put that in. This is a 190 degrees. And this is negative 90, negative 1. So it's a negative 1. And it goes towards the asymptote. So this point here is negative 1, negative 90 degrees. So notice that the sine is from negative 90 to a 90, so cosecant is from negative 90 to a 90. Okay, let's turn that over. Let's do some examples. Again, I've drawn the cosecant graph, not where this is where the restrictions are, because it's easier. Rather than draw its inverse, I draw where it's restricted. So it's restricted from negative 90 to a 90, going up here and down here. So that means its domain, again, repeat, is negative 90 to a 90, and you can't have 0. And its range is, the y, so the y's are greater than or equal to 1 in union with less than or equal to negative 1. So the y's start at 1 and go up, greater than equal to. They start at negative 1 and go down. So let's look at, remember, I repeat again, sine is from negative 90 to a 90, cosecant is from negative 90 to a 90. So if your number that we're looking at for the inverse is positive, so if the number is positive and it got to be greater than 1, then the angle is between 0 and 90 in the first quadrant. If the number is less than negative 1, then it is between 0 and negative 90, which is in quadrant 4. So what about the cosecant of 270? The cosecant of 270 is 1 over the sine of 270. And the sine of 270 is here, so sine is negative 1, so that becomes negative 1. So what about its inverse? So the inverse of a negative 1, right here we got 270, but the inverse on the negative 1, so we got a number, we need an angle. So negative 1 is right here. So if we got negative 1, the angle must be negative 90. And a negative 90 is a negative pi over 2. So it's right here. So this point here, x is 0, y is negative 1. So in relation to cosecant, we have a negative number, so we have a negative 90 on the rotation. And the cosecant of 45, let's look at the 45. 45 rotation is right here. We have a 45 rotation. That means the reference angle is 45. This angle is 45. That's a 90. And on that, we have 45. We got a 1 1 root 2. X is positive, y is positive, the hypotenuse is always positive. So the sine of 45 is 1 over root 2, because 45 is here, opposite over hypotenuse. So the cosecant is hypotenuse over opposite, so it's root 2 over 1, which is root 2. And what about the cosecant of 135? So 135 is up here, right there. Draw a terminal arm perpendicular to the x-axis. So 135 degrees makes this arc here 45. So 135 from here, and 45 is 180. So this is a 45 reference, 45, 90. So this is a 1 root 2. The y is positive and the x is negative. And again, the reciprocal of sine is 1 over root 2. So cosecant is hypotenuse over opposite, which is root 2 over 1, or just root 2. But what about the arc? So the arc of cosecant, cosecant negative 1 is the arc of cosecant of root 2. And root 2 is the 45 right triangle. Root 2 is, if you got a root 2, which is positive, which is right here, roughly 1.4, therefore you have an angle between 0 and 90. And the angle between 0 and 90 in the first quadrant means the angle must be 45 degrees. And 45 degrees is 180 divided by 4. Okay, 2 more to do. What about the arc cosecant of a negative root 2? Again, the angle is a 45, because this is, right here we got root 2, this is negative root 2. But a negative root 2 is right here, and the angle is between 0 and negative 90. So that means the angle is in this fourth quadrant, between 0 and negative 90. So this is negative root 2 in this quadrant. Drop the perpendicular to the x-axis. So that means it's a 45, because it's 1 root 2. X is positive, y is negative. And so a negative root 2 is, that means that the angle is 45. But not only that, the angle is 45 because it's root 2 over negative 1, but it has to be a negative. So negative 45, and that's a negative pi over 4. And we have a 2. A 2 is, a cosecant is hypotenuse over opposites, because it's the reciprocal of sine. Sine is opposite over hypotenuse. This is hypotenuse over opposite. And it's positive, so as a 2 is positive, which means it's up here. So that means the angle must be between 0 and 90. 2 is here, so the angle is between 0 and 90, so we're in the first quadrant. So we have a rotation in the first quadrant, perpendicular to the x-axis, and the hypotenuse, this is 2 over 1, so the hypotenuse 2, the opposite is 1, so that's 2, 1, this is a root 3, x is positive, y is positive, hypotenuse is positive. Since that's a 1, this must be a 30-degree angle, this is a 60-degree angle, so the rotation here is 30 degrees. So the arc cosecant of negative 1 of 2 is 30 degrees. Because it's positive, it's in the first quadrant, and it has to be a 30, because it's hypotenuse over opposite. 30 is opposite to 1, and 30 is pi over 6. So you take 30 multiplied by pi over 180 to convert. 30 into 30 once, 30 into 186. So notice pi over 6, 180 divided by 6 gives you 30. And I forgot, like I did before, let's go back and look. And I forgot on the previous example, I forgot to show you the flip. So this graph that we have right here this restriction I have right here. So this is where we restrict the cosecant graph. So if we restrict the cosecant graph, then there's the restriction. Now I'm going to do the little something that I've learned. I'm going to flip it in the axis. I'm going to flip it in this axis. Y equals X right up through the middle here on the end of my thumb. So I'm going to flip. There it is. And there's his inverse. So again, you can see 1 90 degrees. This is 190 degrees. And this is -1, -90, -1, -90, going towards the asymptote. And going towards the asymptote. And it's horizontal asymptote at theta equals 90. So that's what I do. I remember where it's restricted. So it's restricted. Cosecant is restricted, where sine is restricted from -90 to a 90. So that's all the videos on the inverses of the trig functions. And again, to end this video, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.